As you recall, we have the passwd utility that any user can call to change the password. But on the other hand, we did not have permissions not only to write to the file in which the password hashes are the etc shadow, but also to read how can a simple user change his password. Actually, on Unix-like systems, there is a special trick for this. Let's take a look at the permissions of the passwd utility. At the place of execution permissions for the owner, we see the letter S instead of X. Actually, it is just a special kind of executable permissions that can be set for owner and group. But when we run such file, our initial user ID or group ID is changed to the ID of the file. The process will start with a new effective user ID or group ID equal to the file parameter. And if we run the passwd command, we become the root super user while this program is running. In this state, we can read and write to etc shadow. We can set or unset suite or sgit on symbolic mode using the S character. And in the binary mode of the file, it looks like this. Another question. Do you have any ideas about the implementation of the, for example, PS utility? Actually, it seems pretty simple. We just need to open the special file defmem, read the current process table from memory, and pretty print it to stdout. But for this, we don't have permission to read memory. And in the beginning, the PS utility had the S bit for such reading. But what about today? We don't have a set read bit right now. Why? Because on most Unix-like systems, we have a special proc file system, which is just a rabbit hole for the kernel. It was implemented by Tom Killen for Unix 8th edition in 1984. All processes can be seen as subdirectories in the proc directory. We don't need the suite bit to read process-related data from them. Such a complex revision of the system kernel brings us PS without the suite bit, which is not so little. Because every bit of suite is a potential hole in our security, and it is the daily job of sysadmin to look for new S bits in executable files. For automatic daily monitoring of such tasks, the logwatch utility may be useful. Finally, the first bit of special permissions is a sticky bit. Let's take a look at the permissions for temporary files directory, TMP. So we can see the executable permissions for the owner and group. By the way, what does executable mean for directory? Strange, but these permissions means you can change to this directory. For example, with the command cd. And also we see permission T for directory TMP. Generally, TMP directory is publicly accessible. All users have all permissions to it. Of course, they cannot modify files or directories owned by others. If we don't have such permissions, but they can delete them, because everyone has all the permissions to changing of that directory. And the file permission 1000 or T in character model means only the owner of something can delete it in a directory with this bit.